Alright, so welcome to part 2. This is the video that covers the second half of your homework. This is the video that talks about evaluating trigonometric expressions at special angles, at unit circle angles. So if I could scroll back for a minute, you were evaluating trig expressions, but at non-unit circle values. You were getting answers like √5/2. That's not on the unit circle, or at least it's not at one of our special angles. That's the big difference. You know that your unit circle angles, at least I hope, your 30s, 60s, and 45s, they have coordinates of the form 1/2, √3/2 is in there, √2/2 is in there. These angles on the axis have 1s and 0s. Other than that, if you're not seeing those, then you're not one of the unit circle's special angles. But oftentimes, once I teach this, kids start getting super confused by anything else. If you see a √5/2, you start to freak out. That's not on the unit circle, what do I do? Well, you do this stuff, remember? You do the XYR thing. Don't forget that you have the XYR thing to fall back on when you have angles that are not your special angles from the unit circle. If you see a tangent of √5/2, then that's my way of telling you that you've got a y value that equals √5, an x value that equals 2, and you just have to do a little tiny smidgen of math to find the radius, so that from there you can find the sine and the cosine and the secant and the cosecant. Okay? But okay, let's go do the unit circle ones now. So in this box we're just reminding you what all the definitions are, I guess. Sine is going to be y/r, cosine is going to be x/r, and tangent is y/x. Then everybody's a reciprocal. Remember, sine and cosine, they're not reciprocals. So sine is the reciprocal of cosecant. Notice the one without a co goes with the one that has a co. So that's going to be r/y. Then cosine goes with secant without a co. This guy has a co, this guy doesn't. They go together, r/x. And of course, tangent, cotangent go together. That's always pretty easy to remember. But there's your definition. So from here, it sure would be nice if I just knew the coordinates of all the unit circle angles. And I do. It says sine of 11π/6. So, you know, there's a sort of a process to this. You have to figure out where the hell is 11π/6. And lucky you, maybe you remember that a full rotation is 2π. So if you multiply by 6/6, you can re-express 2π as 12π/6. At which point it should be obvious that 11π/6 is just 1π/6 away. π/6 being 30 degrees, right? So 11π/6 is a 30-degree reference angle that lives in quadrant 4. So it's going to have the same coordinates that 30 degrees has, except its y-coordinate will be negative. So again, my thought process on this is always to sketch out my triangle. It's a 30, 60, 90 triangle, and the longer leg is along the x-axis. So I know that these coordinates are going to be long coordinate first. That's the √3/2 one. Then y is the short dimension. That's 1/2. The x is positive, but the y is negative. There. Those are the coordinates of this point. They want sine. Well, sine is y/r, but the radius is 1 when we're doing a unit circle problem. So sine is just literally just the y, which is -1/2. There. I evaluated that trig expression by kind of just drawing a sketch and thinking it through. And I can do the same thing for tangent. Now, for this, I'm going to want to get rid of this. If I get rid of this, I mean shrink it, move it over there, so you can still kind of see it. But now we're doing number 2. So 3π/4, where the heck is that? Well, the x-axis over here is 1π, so that's 4π/4. So 3π/4 then is here. It's a 45-degree reference angle living in quadrant 2. So they want the tangent of that? Alright, no problem. Because I have memorized that 45-degree reference angles have coordinates of √2/2 and √2/2. And in quadrant 2, it'll be a negative x with a positive y. So tangent then is going to be the y over the x, so it's root 2 over 2 over root 2 over 2 negative. Well, of course, these cancel out. You're dividing something by something that's equal to it. That whole thing goes to 1. And since one of them was negative and one of them was positive, you get negative 1. That's it. Number 2 is negative 1. So hopefully you're understanding the process. Number 3 is back in degrees, so that shouldn't be bad. 225 would be 180 and then 45 more. So it's another 45-degree reference angle, but this time you're in quadrant 3. They want cosine. Well, cosine is x. And the x coordinate of our 45-degree reference angle is root 2 over 2. But that's what it is in quadrant 1. We're in quadrant 3, so of course we need negative root 2 over 2. And you're done. That's the answer to that one. What's the tangent of 240, you're thinking? And the answer is, of course, 240 was a 180-degree rotation plus 60 more. So we're talking about a 60-degree reference angle. 60 degrees means short y, short x, long y. So it's 1/2 and then root 3 over 2. Then in quadrant 3, both coordinates are negative. And if you want tangent, it's the y over the x. So it's negative root 3 over 2 over negative 1/2. Kill the 2's, kill the negatives, and you get an answer of plain old root 3. Got it? Okay. What can you do if you don't got it? If you don't understand, then I don't know, man. Watch another YouTube video. Someone can teach you better than me, I hope. Anyway, let's keep going. Cosine of pi. Well, pi is right on the axis. This should be an easy one, because those coordinates are an x of negative 1 and a y of 0. Remember, our radius is 1, so I've gone 1 unit left and I didn't go up or down at all. Cosine is just the x coordinate, so negative 1. You're done. Evaluating these trig functions boils down to simply finding your angle on the unit circle and figuring out what the coordinates of the point of intersection are going to be. And you know all the coordinates from quadrant 1. We derived them in class, right? I'll go over it again, I guess, because I guess it'll come up again. But I don't think so, actually. The next page just starts hammering you with more practice. So I guess if anyone didn't already know, here's where these came from. I guess let me grab this guy. I guess let me just do it here, why not? But we had this whole unit circle and we filled in everything. We said this first blank was meant to be the degree measures of all these angles, which should be a piece of cake. It's going to be 0, 30, 45, 60. I'm not going to keep doing this because you guys can do that part, I'm sure. The radian measures are a little tougher. This is 0, this is pi over 6, pi over 4, pi over 3, pi over 2. If you're trying to number the radians like you're on a clock, like you're going around a clock, you're not going to have a good time. Obviously from 6 to 4, well, the denominator changed by 2. Then from 4 to 3, the denominator changed by only 1. Like that alone probably feels weird to some people if you don't really understand how this is working. So it's not like you can just do that. But kind of you can. I was trying to explain in class that if you want to count your way around the unit circle, you sort of can. But here's what you got to do. When you're doing the 30s and the 60s, you got to ignore the 45s. Because we gotta be breaking everything down into even bits. So if I'm going by 30s at a time, then everything's chopped up evenly, right? You can actually see that. You can actually even see there's 1, 2, 3, 4, 5, 6 even slices. As soon as you notice that, it makes a hell of a lot of sense for this first slice to be pi over 6, because the whole top half of the circle, those 180 degrees are pi. This angle literally takes pi, the whole 180 degrees, and chops it into 6 equal parts. Of course that's pi over 6. Now the nice bit is, take a look at the next guy. It's literally 2 pi over 6's. The next guy is 3 pi over 6's, 4 pi over 6, 5 pi over 6, 6, pi over 6. So if you take the 45s out, then you're now counting by pi's over 6. You get 1 pi over 6, 2 pi over 6, and then you go, but Mr. F, you said pi over 3. Well, no duh. Guess what 2 pi over 6 is? You got to reduce it. Divide by 2, you get pi over 3. After 2 pi over 6, you get 3 pi over 6. Well, again, reduce. When you reduce that, you get pi over 2. Then you get 4 pi over 6. When you reduce that, it's 2 pi over 3. So we can start filling in these other quadrants now. You get 4 pi over 6, then this is 5 pi over 6, and that has the good graces to not even be reducible. You just get 5 pi over 6. Then you get 6 pi over 6, that's pi. Now, the bottom half, I can keep counting. Just remember, you got to skip the 45s. So this was 6 pi over 6, this must be 7 pi over 6. This is 45, so skip it. You got to go a full 30 degrees, so you got to go past the 45. Then you get 8 pi over 6, that reduces to 4 pi over 3. So where was I? 6, 7, 8. This is 9 pi over 6. Divide by 3. That's 3 pi over 2. So this is 10 pi over 6, which is 5 pi over 3. This is 11 pi over 6, which does not reduce. And then finally I'm back to 12 pi over 6, which is 2 pi. 0 and 2 pi being coterminal. So we did it, we labeled all those. Now, those 45-degree angles that we whited out, bring them back if you can. I don't think I can. I'm just going to do that. I'll just make it a little bit transparent. There, now you can see them again. But for those, this time skip your 30s and 60s, but don't skip your 90s. We want to count by 45s. So we want to count 45, 90, 135, 180, 225, 270, 315, 360. But I'm literally, if I do that, I'm just counting by pi's over 4. So I would have 1 pi over 4. We already knew that. This guy must be 2 pi over 4. That reduces down again. So this guy then is 3 pi over 4. So that's 3 pi over 4. Then 4 pi over 4, so this must be 5 pi over 4. Then 6 pi over 4, so this guy must be 7 pi over 4. But now you've finally done it. You've labeled every single angle in terms of pi. That's not hugely useful. What's useful is making sure that you know all this off the top of your head. You better feel pretty comfortable now just knowing. Again, the real trick in my mind is remembering that pi is your benchmark. So if this is 6 pi over 6, then of course the very next guy is 7 pi over 6. If it's 4 pi over 4, then the very next pi over 4 is 5 pi over 4. This is the quadrant where everything's bigger by 1. This is the quadrant where everything's less by 1. You think of this as being 12 pi over 6. So 1 less than that is 11 pi over 6. You can think of this as being 16, I don't know what I'm talking about, as being 8 pi over 4. So 1 less is 7 pi. I wrote a 3, geez. It's late over here. Alright, 7 pi over 4. You could also think of this as being 6 pi over 3, which means 1 less than that's 5 pi over 3. That's a good way to maybe think about this. Anyway, I think what I really promised y'all was that we would talk about the coordinates. I'm just going to scroll down. Then I'm going to paste. And it's going to paste way up at the top, and I won't be able to find it. There we go. Okay, so where the coordinates come from, I talked you through this before. You guys are fast forwarding, hopefully, if you already know this. But basically, well, all right, sure. Start with 0. I mean, 0 is obvious. Your radius is 1, so your x is 1, and your y is 0. Same with 90. Your radius is 1, so your y value up there would be 1, and your x would be 0. But where did these coordinates come from? Well, they came from our special right triangles, because remember, from here I could drop straight down. I could run over from the origin. And I could have a hypotenuse. Well, as a pi over 6 radian angle, this is 30 degrees. This is our 30, 60, 90 right triangle. We said this horizontal leg literally is the x-coordinate. This vertical leg literally is the y-coordinate. The problem is I don't know either, but I do know that we are a unit circle. So my hypotenuse is 1. Well, in a 30, 60, 90 triangle, the short leg is half of the hypotenuse. So half of 1 is a half. So this triangle has a leg whose length is a half, so the y-coordinate is 1/2. Then the other leg has to be that short leg 1/2 multiplied by √3. That's just the rule for a 30, 60, 90, is the long leg is longer than the short leg by a factor of √3. Yes, it's always √3. So that's what gives us an x-coordinate of √3 over 2. You just multiply those, you get √3 over 2. But that's where those coordinates came from. Then you can always bounce that to the other 30-degree reference angles. It's still going to be √3 over 2 and 1/2. If I bounce it down to the 30-degree reference angle in this quadrant, it's going to be √3 over 2. You think this was meant to be a fraction bar, or do you think it was meant to be a line? I don't like the looks of that. I like it as a line. Turn that off. Can't turn that off. Turn that off. I can't like undo anything. Okay. Train of thought. I've lost it. I think I was saying, oh yeah, I wanted to erase this garbage. And I wanted to write my answer on the line. But this is still going to be √3 over 2 and 1/2. The angle over here, 30-degree reference angle, still going to be √3 over 2, 1/2. The only thing that changes as you go into the other quadrants are the signs. Obviously in this quadrant, x will be negative. In this quadrant, x will be negative, and so will y. And in this quadrant, it's only the y that's negative. So you can very quickly take your answer from quadrant 1, bounce it into the other quadrants. We can do the same. Let's do the 60-degree angle, skipping the 45 for a moment, because 30 and 60 are related. That was the least straight line I've ever drawn. That one's good. That one kind of stinks, but I'll live with it. All right, it's the same deal. My hypotenuse is still 1, but my 30-degree angle is up here this time, because my central angle is 60. So the side that's opposite from 30 is now my x-coordinate, and that's still got to be 1/2. So I'm going to have the same coordinate, but this time it's my x-coordinate that's a half. It was the y-coordinate over here. Now I've got to take the 1/2 multiplied by √3 to get this vertical component. That's going to be the same √3 over 2. So these coordinates that maybe sounded like just gibberish to you guys before, they really have a very firm grounding in our special right triangles, and I hope this is making sense. So finally we've got the 45-degree angle. It fits in right here. It's got a hypotenuse of 1 as well. Now this is the one where the legs are supposed to be the same. The legs are x and x, and the hypotenuse is x √2. So if the hypotenuse is the leg multiplied by √2, then the leg is the hypotenuse divided by √2. So whether I'm talking about the x or the y, it's going to be 1 divided by √2. But then you remember, we don't leave it like that. We would multiply by √2 over √2 to get √2 in the numerator and normal 2 in the denominator. And those are the 45, 45 coordinates. It's √2 over 2 for both the x and the y. But that's it. You're now looking at a complete list of every coordinate that matters on the unit circle. You've got zeros and ones, you've got 1/2s and √3s over 2, and you've got √2 over 2s. That's it. Those are the only numbers you need to memorize. And it's pretty easy to remember that 1s and 0s go on the axes, and sometimes they're negative. This would be negative 1, 0, but they go on the axes. It's also kind of easy to remember that root 2 over 2 and root 2 over 2, the ones that are the same, have to be on a 45-degree angle, because it's 45, 45, 90. It's literally an isosceles triangle where the x and y are the same. So that's a root 2 over 2 and a root 2 over 2. But this is negative. So the only thing that could possibly confuse you is keeping the order straight on your 30s and your 60s. And I've already alluded to this a couple of times. The trick is to, the trick is to remember that 1/2 is shorter than root 3 over 2. 1/2 is 0.5, and root 3 over 2 is 0.866. That's the bigger one. If you didn't know why, well, the square root of 3 is bigger than 1, isn't it? 1 times 1 is only 1. So the number that you square to get 3 has to be bigger than 1. So that's clearly the bigger thing. It is very obvious in this blue triangle that the y is longer than the x. So you put the short length in for x and the long length in for y. Look at this red triangle. It is very obvious that x is longer than y. So you put the long number in the x position and the short number in the y. I'm sorry, but this is not that hard if you think about it the way I just explained it. That's my opinion. Let's go do some problems. God, I don't want to. All right, what's the cosine of 300? Well, 300 is a 60-degree reference angle, but it's down here in quadrant 4. But cosine is x, and x's are still positive in this quadrant. So basically, I don't even have to worry about the fact that I'm in quadrant 4. It's going to be the same answer as if I was in quadrant 1. That answer, by the way, is my x-coordinate, which is the short one, so it's positive 1/2. And I'm done. Negative 225, let's see where that is. Negative 225 has me rotating clockwise. So 225 would be a 45-degree reference angle that lives in quadrant 2. Cosine is x. X's indeed are negative over here in this quadrant. So with a 45-degree reference angle, you know it's root 2 over 2. But living in quadrant 2 and being an x value means you know it's negative. So it's negative root 2 over 2. 135, negative 135, that's pulling up 145 degrees, or sorry, that's pulling up 45 degrees shy of 180. That's 135. So we're talking about 45-degree reference angle again, but we're in quadrant 3. So for sine, which is a y-coordinate, it's going to be root 2 over 2. And it's going to be negative, and then you are done. That's it. This is how your thinking should be. Find the quadrant you're in, find the reference angle. Think about what coordinate you need, and then think about whether it's positive or negative. You answer those questions, you're golden. So where's negative pi over 6? Well, pi over 6 is 30 degrees, and they want me to rotate down, so I guess I'm here. Oh, I'm sorry, we are way off the screen. Okay, so it's a 30-degree angle. We're down here in quadrant 4. Now, tangent is always the tricky one because tangent wants both the y-coordinate and the x-coordinate. Sine and cosine are easy because you literally just pick one coordinate at a time from the coordinates you've already memorized. But with tangent, you got to do some work. So if I'm 30 degrees, then y is the short dimension. So that'll be a 1/2 in the numerator, and it'll be a 1/2 that's negative because I went down. X will be a root 3 over 2. So the good news is you got a complex fraction, but the denominators are the same. So you know you can cancel them out. So now I'm just looking at negative 1 over root 3. Well, you are supposed to rationalize your denominator. So you're going to get a final answer of negative root 3 over 3. That's going to be your tangent. Your tangent is negative root 3 over 3. Notice that's not a coordinate from the unit circle. That's a combination of two coordinates from the unit circle. It's a combination of the 1/2 and the root 3 over 2's. All right, that's 1 through 9. Let's do a bazillion more of these. All right, cosecant of 7 pi over 4. This is actually the first reciprocal function we're seeing. So just remember, this is the reciprocal of sine, so it's going to be the reciprocal of y. So it's going to be 1 over y. Or it's just going to be the y coordinate, which is a fraction flipped, right? So where's 7 pi over 4? Well, remember, a full rotation 2 pi is 8 pi over 4. So 7 pi over 4 is 1 pi less. So when you see 7 pi over 4, you're thinking about that rotation. It's dropping you into this quadrant. Now we want the y coordinate. With pi over 4, that coordinate's going to be root 2 over 2. It's the y coordinate, and we're down in this quadrant, so it's negative. But finally, we want the reciprocal of this because we're cosecant. So the real answer here is negative 2 over root 2. But I lied. That's not the real answer either because you got to clean that up. So you multiply by root 2 over root 2. And the real final answer is negative 2 root 2 over 2. Oops, I lied. You can cancel those 2's. So the actual final, the for real final answer is negative root 2. Hey, would it be a really good idea to remember that the reciprocal of root 2 over 2 is just root 2? Seems like it'd be a good idea. Seems like it'd be a waste of time to always flip and rationalize just to land on the same thing over and over again. You should just memorize that the reciprocal of root 2 over 2 is root 2. Good idea. All right, cotan 225. I just feel like we've already done this. It's all the same. Just start blending together. 225 is your 45-degree angle in quadrant 3 because we rotated like that because we're positive. 225 is a 45-degree reference angle. So your coordinates are root 2 over 2 and root 2 over 2. And they're both negative, which means cotangent, it doesn't even matter who's x and who's y because they're the same. You know that for cotangent what you're doing is dividing both of them. So the negatives will cancel and you'll get 1. You'll get 1. Positive 1. All right, 12. What's the secant of 2 pi over 3? 2 pi over 3 is a 60-degree reference angle in quadrant 2. Now, I don't know. I'm saying that pretty darn fast. Maybe you guys have to think this through a lot harder. But remember, it's fine if you convert to degrees. Like, I don't want you to do that, but on the quiz, I know you're gonna. Remember, the trick was just let pi be 180. And then 180 divided by 3 is 60. And 2 times 60 is 120. So you know you're talking about a 120-degree angle. You know you're talking about a 60-degree reference angle. Do what you gotta do. Do what you gotta do to nail it down. But now that it's nailed down, you know that you're talking about secant. That's the reciprocal of cosine, so it's the x-coordinate that matters. The x-coordinate's going to be the small one, so that's a half. But I want the reciprocal, so it's 2. But I'm in quadrant 2, so that x was negative, so it's negative 2. That's what you got to do, kids. You gotta answer a bunch of teeny tiny questions. You think, all right, what's my reference angle? What quadrant am I in? What coordinate do I care about? Do I want the reciprocal of it? Is it positive? And once you've answered all those questions, you're done. So here, what's the deal? Our reference angle was pi over 3, so 60 degrees, but we're in quadrant 2. So we want the x-coordinate because it's cosine, but it's the reciprocal, so it's negative a half, but it's the reciprocal, so it's negative 2. There's all these like fine little steps. All right. I don't think I can do the rest of these. I don't feel like explaining any of this anymore, so I will give you the answers because I said I would. So cotangent 90, I'd give you the answer, but I have to think it through. So I'll still think out loud, but I'm going to do it a hell of a lot faster. All right, cotan 90, 0, 1. Cotangent is actually x over, so it's 0 over 1, so it's 0. If this was tangent 90, it would be undefined. But since we have 0 in the numerator, we just get 0. All right, cosecant of 2 pi. 2 pi is right here, so that's 1, 0. Cosecant reciprocal of sine, reciprocal of the y value. Well, 1 over 0, I'm pretty sure, is undefined. Cotan 240. This is a tough one. I can't glaze over this. I'll do this one out a little more formally as I write in a place that you can't see. All right, so 240 is 60 degrees more than 180. So you should know we're in this position, the one with a long y value. So it's root 3 over 2 as y, 1/2, both negative. It's cotan, so we're doing x over. So it'll be negative 1/2 over negative root 3 over 2. Kill the 2's, and you get, kill the negatives too, you get 1 over root 3. Which when you rationalize the denominator is positive root 3 over 3. It's positive. All right, secant pi over 6. Pi over 6 is 30 degrees. Secant goes with cosine. Cosine is root 3 over 2. So this would be 2 over root 3, which you really have to give me as 2 root 3 over normal 3. So it's these reciprocal functions are the ones that can be a little bit ugly. The reciprocal of root 3 over 2 is 2 over root 3, but you got to clean it up, and then you end up with this ugly looking one. All right, 270. 270 puts you on the y-axis down here, negative y. So 0, negative 1. Cosecant goes with sine. Sine goes with y. So reciprocal of negative 1 is negative 1. Okay, done. Now there's a bazillion more. Blah, 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 explain. Blah, 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 don't care. I talked about reference angles. I don't need to do it again. I don't care, but I explained all this too. All right, so here's just a bunch of questions I'll walk you through. I think I said odds, so I'll do the odds and that's it. So the other thing I said is when it comes down to quiz day, I'll give you a unit circle. I'll give you a single sheet that's got the unit circle on the front. Unit circle will be on the back too. So by the time this unit circle gets all cluttered, you can flip the paper over, you'll have another one. But negative pi over 6, where's that? You should pretty quickly be able to go, boom, right here. Negative pi over 6, it's that guy. Sine is the y value, so what's that going to be? Negative 1/2. Got it. Done. So by the way, where it says solve, that's not really the right verb. The right verb here is evaluate. Solve is what you're doing when you're finding the value of a variable. There's no variable here. This is just an expression. You have to find the value of it. It's tantamount to as if I had said log base 7 of 49, which, God, I hope you haven't forgotten. There's no variable here. This is just an ugly expression that has a value, right? What's the value of it? 2. So you evaluate it. You got 2. It's the same as if I'd given you a cube root of 64. That's just some ugly expression. You evaluate it. It's 4, right? Well, all of these trig expressions, they have some value. You find them on the unit circle, so you just have to do that. All right, pi over 3, where is that? Right here. Boom, pi over 3. Cosine is x. It's the short one, so positive 1/2. And I'm done. Should you be able to do it this fast? Yes, you should, because you studied and you practiced. If you don't finish on time on Tuesday, it is because you did not practice enough. It's not because the quiz is too long. All right, when I see an angle like this, I'm not trying to whip around the unit circle a bunch of times. This is where you have to, your memory has to kick in for coterminal angles. Remember, I could take negative 1620 and I can add on a whole mess of 360s. How many 360s can I add on? At least 3. And I don't feel like doing that. I don't know, if you have your calculator, you're hitting the buttons, right? But 3 of these is 1080. So what's 1620 take away 1080? Well, that's not even enough. I know I want to add more. I probably want to add on 5. And I am just going to use a calculator. Let's pretend you had your 4 function, or one of mine. So 1620 negative negative 1620 plus 360 times What have you done? No. Why are you like this? You're horrible. All right, sure. Great. All right, 180. Anyway, after all that math, if you just add 360 to this 5 times, then you'll eventually get to a positive 180. So, okay, that means these are coterminal now. This is not a reference angle anymore. It's not like I'm changing it to an angle and I'm in the wrong quadrant. Well, I'm in the right quadrant. Remember, 180 and negative 1620 are coterminal. They literally lie right on top of each other. Anyway, I'm here. That means my coordinates are 1, 0 in that order. The order is very important here. Tangent's y over x. So the fact that 0 is in the numerator means we're not undefined, we're just 0. There. That one took too long. But I was dealing with the really big angle. You really have to, you don't have to, but it behooves you to take these really big angles and project them back into something that falls between 0 and 360. And you do that by just adding 360 a bunch or subtracting 360 a bunch if the angle is really big. Speaking of 5 pi over 2, that's really big. But I don't know, maybe this one's more obvious to you guys. 5 pi over 2. Well, 2 pi is 4 pi over 2. So I'm really just taking away 4 pi over 2 once. This is me taking away 360 basically. I'm taking away one full rotation. Leaves me with 1 pi over 2. So I know that the tangent here is the same as the tangent of 1 pi over 2. I also know that 1 pi over 2 is up here. I also know the coordinates are 1 and then 0, which means in the right order, at 90-degree reference angles, we've got the 1 in the numerator, the 0 in the denominator. So our tangent is undefined. That's 1, 2, 3, 4 out of a total of 173. We're going to be here a while. All right, let's do these. Okay, guess what? You'll have a unit circle, bada bing. It says 450. That number is small enough that you might realize it's just 360 plus an extra 90. So we're talking about this guy again. This guy's getting a lot of work in the past few problems, but it's 0, 1. Secant is the reciprocal of cosine. Cosine is x. Reciprocal of 0 is undefined. So that one's done. 13 pi over 2, go away. Give me a fresh one. 13 pi over 2, where on earth could that be? Well, call me crazy, but I feel like 13 pi over 2 is the same as 12 pi over 2 plus an extra pi over 2. And I can't help but think that 12 pi over 2 is the same as 6 pi. And I can't help but think that that's the same as 3 times 2 pi. Ideally, you could do most of that math in your head, but what's the meaning of this 3 times 2 pi? It literally means we've gone 1, 2, 3 times around, then an extra pi over 2. Hey, guess where we are? Literally the exact same spot, same point, which is 0, 1. But I hope that math made sense. Basically, I want to get rid of all those 2 pi's. I could take this, I could subtract 2 pi, subtract 2 pi, subtract 2 pi. I'd be left with pi over 2. That's your thought process. Anyway, I'm sine. Sine is y. This is 1. And I'm done. Next one. Negative 225. That means I've gone 180 and then 45 more. So I'm here. I'm in this position. I want sine. Sine is the y value. So it's root 2 over 2. Because they're both root 2 over 2. And in the quadrant I'm in, this guy's negative, but I don't care. I'm sine. Sine just wants the y value. So it's positive root 2 over 2. Okay. Cosine. All right, again, thought process. Full rotation is 8 pi over 4. It's a negative angle, so I guess I'm going to right here. So I'm in quadrant 1. And I'm cosine. Cosine is the x-coordinate, which would be root 2 over 2. Don't care. All done. Moving on. All right, 150. 150 is a 30-degree reference angle, so I'm here, right in this quadrant. Quadrant 2. It's sine. Sine is the y value. The y value is short, so it's 1/2. And it's positive, if that's not obvious. All right, so you guys are starting to see the pace at which I feel like you should be able to move. You should be able to move pretty darn fast. 19 pi over 6, that ought to slow you down a little bit until you go, 19 pi over 6? Well, if I take a clean multiple of 6, like 18, I hope eventually your head gets to a place where you go 19 pi over 6. That's 12 pi over 6, meaning a full rotation plus an extra 6 pi over 6. That's a half rotation plus a pi over 6, which is an extra 30 degrees. If you can get here, then you're ready to navigate the unit circle really easily. So the 19 pi over 6, that's me going bzzz, 12 pi over 6. 6 more, that's 18. 1 more, I'm there. That guy right there is what 19 pi over 6 looks like. Guess what? It's sine. Sine is y. Y is the short one. It's negative, negative a half. Once you figure out where you are in the unit circle, the rest is cake. All right, tangent negative 35. All right, negative 135 is going to pop us right here. 135 is a 45-degree reference angle. Pro tip, if it ends in 5, it's 45, right? Everybody else is 30, 60, 90. Everybody else ends in 0. So you know at least that much. I want tangent. By now you should know tangent at 45 is 1, because it's always going to be the same number divided by itself. It's root 2 over 2 divided by root 2 over 2. That gives 1. Now wait a minute. If I'm in a different quadrant, if I'm over here, then I might be doing a negative divided by a positive, and I'll be negative. But because I'm in quadrant 3 and they're both negative, this will come up positive, and it will be positive 1. So we're done. Secant of 11 pi over whatever. 11 pi over 4. All right, where's that? Again, thought process should be, we're rotating this way. Here's 4 pi over 4, 8 pi over 4. This would be 12 pi over 4. That's too small. Back it up. Must be right here. Beep. So, same spot. Secant wants the reciprocal of cosine. So it wants the reciprocal of the x-coordinate. And we said it would be a good idea to remember that the reciprocal of root 2 over 2 is just root 2. But it would also be a good idea to remember that we're in quadrant 3, where both coordinates are negative. So you better give me negative root 2 for number 12. We're only on 13. It's almost 1 in the morning. I'm going to be doing this for quite some time, aren't I? All right, sine 330. That's 30 degrees less than 360, so I'm here. Sine is y, so negative a half. Next. Negative 4 pi over 3. Again, here's 3 pi over 3's. And an extra pi over 3 would be 60 degrees more. So there's your 4. I could literally actually show you. There's your 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. It would be awesome if you could actually see this. It's 60-degree chunks at a time, right? So it's here, here's your third, there's your fourth. That's why I'm landing right here. Now I want sine. Sine is y. Y is the long one, root 3 over 2. Done. All right. The positive 4 pi over 3 would just have us rotating around to here, which is the guy that's symmetrical with this one. It's just reflected over the x-axis. So that means the y value is now the opposite of what it used to be. It's now negative root 3 over 2. Okay. Then you get this 1140 bullcrap. So you bust out your calculator, and you see what you get when you subtract 360. You get 780. At which point, hopefully, you recognize you could just be taking away 720, which is 2 360s to be left with 60. So I guess that's 1, 2, 3 turns plus 60 more is the 1140. So what did we learn? 1140 is coterminal with 60. That means you can literally just rewrite the problem as the sine of 60 instead. And I'm not even going to draw a picture for this one. Come on. That's going to be the y coordinate. It's going to be root 3 over 2. Okay, got there. 17. Cosine 120. 120 go burr. Cosine is x's. Negative root 3 over 2. Negative 8 pi over 3. Geez, where could that be? Let's see. That's 6 pi over 3. 7, 8. So I guess I'm here. Cosine is x's. Negative a half. 540 is a rotation and a half. That's a good thing to just memorize. 540 is 360 plus 180. So we're talking all the way around, then halfway around. So we're here. It's cosine. Cosine is x. So this is negative 1. 5 pi over 3. We didn't do that already? I guess not. So remember, a full rotation is 6 pi over 3. So 5 pi over 3 is right here. Oh, that's terrible. So yeah, 5 pi over 3 goes to right there. Cosine is x. That'll be a half. All right, if you're fast forwarding around the video, if you fast forward it up to these problems, I'm doing these a lot faster now. If you want to go back to numbers 1, 2, 3, 4, whatever, that's where I spent a lot more time explaining. So this one, 3 pi over 2. 3 pi over 2 is 270. It's right here. How do I know that? Because this is 1 pi over 2. It's 90 degrees. So 1, 2, 3 pi over 2s would literally put you here. Cosine is the x-coordinate, so it's 0. Cotangent negative 90. Well, negative 90 is the same spot. But it's cotan now, so be a little careful. This will be 0, negative 1 in that order. Cotangent wants x in the numerator, which means we're getting 0 in the numerator, which means we're not undefined, we're just 0. So cotan negative 90 is 0. Negative 7 pi over 3. I hope this is starting to feel like second nature to you. It's starting to feel pretty good for me. Negative 7 pi over 3 would be, that's 6 pi over 3. 60 degrees more. Right there. Tangent. Tangent wants y in the numerator. So if I got the root 3 over 2 over the 1/2, kill the 2's, I'm getting root 3. But wait, we are in a quadrant where one coordinate is negative. So if I have a negative over positive, then this needs to be negative overall. So your answer better be negative root 3 there. Okay. And then finally, on this page, negative 2 pi over root 3. Pi over 3 is 60 degrees, right? So we're going 1, 2, and we're here. Tangent of this is still short coordinate, long coordinate. That means I'm still doing y over r, kill the 2's, kill the negatives, we will get positive root 3. No negative this time. All right, negative 3 pi. Well, your multiples of pi are always on the x-axis, and your even ones are always over here. It's 0, 2 pi, 4 pi, 6 pi, 8 pi. So your odd ones would be over here. This would be 1 pi, 3 pi, 5 pi. So 3 pi means I'm going backwards, and I'm landing here. I'm here. I'm tan. Negative 1, 0. So tangent here has y in its numerator, so it's 0 over negative 1. So that's 0, not undefined. Negative 22 pi over 3. All right. That's the same as what? Negative 21 pi over 3. Take away an extra 1 pi over 3. That's a negative 7 pi minus an extra pi over 3. This is odd, remember, and I'm going in the negative direction, so I guess I've gone around 1, 2, 3, 4, 5, 6, 7, and then an extra pi over 3. Pi over 3 being 60 degrees. So that angle's right here after a bunch of rotations. But I'm here, and I know my coordinates are short one, then the long one, short one, negative, my arrow. All right, again, it's y over x, so this guy's going in the numerator. So when the 2's cancel, you get root 3 over 1, which is root 3. But we're in quadrant 2. Tangent's negative there, so it's negative root 3. Again, this is probably feeling pretty repetitive to you, but that's how you're going to learn this, is the repetition. Okay? I'm suffering through it. We're suffering together. It is 1 a.m. I'm doing this right now. So put in the work. You got to put in the work. All right, 11 pi over 3, where is that? It's 1 pi over 3 away from 12 pi over 3, which would be a full rotation. So I'm going negative, so we're going to go all the way around, all the way around. Actually, we're going to come up shy of 12 pi over 3. We're going to be 1 pi over 3 away. So erase, erase, erase. I know that's not a perfect match, but we're here. We're in this position. Tangent there, let's see, 1/2 root 3 over 2. It's root 3 over 2 over 1/2 again with the 2's canceling, giving us root 3. Again, now we've got cosecant 5 pi over 6. By now, if you're actually going through all this with me thoughtfully, then you should know on sight where 5 pi over 6 is. Boom, right there. Okay, and you should know cosecant is the reciprocal of sine. Sine is y. The y coordinate is 1/2. Reciprocal of 1/2 is 2. Done. Well, that's cool. I'm just now noticing you guys can't even read these numbers. I think it's not the end of the world, I guess. You're probably following along just fine. I'm going to say you are. Okay, guess what? unceremoniously, we just did the last one. That one was the last one. We're done. We're done evaluating these trig functions. But now is where we have to do something completely different. We have to work backwards. This was the final lesson. This was the lesson that made me push the quiz back. So this might be the thing you've all tuned in for. We're an hour deep in the video already. I'll have to put some kind of note or something telling you guys to fast forward. But let's do this. Let's talk about how we would think this through. Your thought process for a question like this should be that I want to find every single angle where sine is a half. Well, sine is a y value. So where on the unit circle does sine equal 1/2? That's a 30-degree reference angle, isn't it? And if I want y to be positive, then I don't have to just be in quadrant 1. I could also be in quadrant 2. That means this position's possibility too. So technically, because the instructions say find all, then we have to find a way to write an expression for all of these values. So one thing we could do is say, all right, 30 degrees is correct, but then we got to list everybody coterminal with that. So remember we said we could add on 360 times k, as long as we let k be in the set of integers. All right, there you go. This expression literally represents every angle that is coterminal with this angle. Because if I add on 360 to get 390, then I've got 30. Now I've got 390. That's a new angle. I could let k be 10, and I get what? 3630. So that whips around 10 times. Then it goes the extra 30, and it's in the right location. So this is all the guys whose reference angles are 30, and they live in quadrant 1. But that's not going to do it, because we need all the reference angles from quadrant 2 that are 30 as well. So that we would sort of seed this with 150. Now instead of starting at 30, you start at 150, but you're still going to add on a whole mess of 360s, making sure that you always use clean multiples of 360 by making sure that k is an integer. There you go. This is technically the right answer to 29. But this won't really be what I'm asking you on the quiz. We said you're going to only give me the answers that live between 0 and 360 or 2 pi. It's really going to be 2 pi. What I'm trying to do is make it clear that what I want is I want only those answers that live in the first rotation. So you start at 0. You may go around once and tell me all the correct answers you encounter. We encounter 30 and 150. So for 29, you'll just give me those numbers, 30 and 150. Except, okay, super psych. You can't give me degrees. Of course you can't give me degrees. What is this, on level? You're going to give me radians. So in radians, that's pi over 6. And 5 pi over 6. But that's it for 29. Hopefully you understand that what just happened is we really based our answer entirely off of the fact that sine is y. And the only two spots where y is equal to 1/2 are these 30-degree reference angles. And that's it. So from there, we go to the next one. It's still about sine, but sine is 0. So where on the unit circle does y equal 0? That would be right here and right here. Those two angles are 0 and 180, which is pi. So let's keep in terms of radians. The two answers are 0 and pi. Of course, remember there's more. 3 pi would work, 4 pi would work, 5 pi would work. But you only have to give me those first two. Alright, the next one is asking when does sine equal 1? Sine is y value, so where on the unit circle does y equal 1? Well, there's only two spots, here and here. So now, you'd be saying this variable is equal to pi over 2 and 3 pi over 2. Pi over 2. My brain was thinking ahead to this 3. Pi over 2 and 3 pi over 2. Alright, next. The next one's asking, when does sine equal root 3 over 2? Which is basically just saying, when does y equal root 3 over 2? Root 3 over 2 is the long value, so it must be here. It must be the 60 degree reference angles. And since it's positive, it must be quadrant 1 and 2. So those are pi over 3. Oopsies. Don't say y equals. We're solving for x, remember. So you'll say x equals pi over 3 and 2 pi over 3. All right, that takes us up to 32. All right, -1, it's sine again, so it's a y value. This one's a little different because there's only one spot where you can get a y value of -1, and it's right here. And if I'm only giving positive angles in the first rotation, then that is 270 degrees, but really it's 3 pi over 2. And there aren't any other answers, at least not that live within our restricted window. Okay, first thing to notice about this is we've switched to cosine, so we're talking about x's. They did not rationalize their denominator. So this is really root 2 over 2. That should have you thinking 45 degree reference angles. And because they're negative, you should be thinking 45 degrees here and here. Those are both negative root 2 over 2's. So what are those angles? Those are pi's over 4. So if this is 4 pi over 4, then it's 3 pi over 4 and 5 pi over 4. That's a 4, but my little writing tablet likes to connect the dots. But that's the answer to 34. No, I was afraid of that. So this answer is getting pulled with this. Sorry, write it down. Okay, now cosine wants to be root 3 over 2. Cosine is an x, and root 3 over 2 is long, so must be here and here. Must be these 60 degree reference angles. So I guess this variable, which is trying to be phi, is 5 pi over 6. And this is 6 pi over 6, so this is 7 pi over 6. And we're going to lose that 7 pi over 6 as I drag this away. But remember, it's both of those. In fact, I'm going to leave it there so we don't screw this up. When is cosine equal to -1? Well, cosine is still x, so the only place where x equals -1 is all the way here at pi. And there's no other correct answer. Because remember, we're not doing negatives. Negative pi would technically be correct, but I'm restricting you, I'm telling you, only give me the answers that live between 0 and 2 pi. Okay, when does tangent equal 0? This was a tricky one for people, but if you remember that tangent is y over x, then you're looking for where y equals 0. And on the unit circle, y equals 0 when x is 1. So you're basically looking for the point 1, 0, which only exists here. So that's 0. Phi equals 0, and no other answer works. You don't give me 2 pi because 2 pi is not in the range. 2 pi is where I'm telling you to stop. So give me 0 only. All right. So the slightly quick way to do this is to realize that 1 over root 3 must be coming from 1/2 over root 3 over 2, and the 2's have canceled. So since tangent is y over x, you're looking for where y equals 1/2. That's 30 degree reference angles. Now wait a minute. This is slightly tricky. With tangent, it's not going to be the place where both of the y coordinates are positive 1/2. The other way for tangent to be positive is for us to have negative 1/2 over negative root 3 over 2. So you got to remember that tangent is not positive in quadrant 1 and 2. It's positive in quadrant 1 and quadrant 3. That's a pretty big difference from the other 4 functions. So our correct answers now are sort of across from each other diagonally rather than horizontally or vertically. So tangent is different that way. Hopefully you're putting that together. Do the work. If you do enough practice problems, you see the patterns for yourself. So what is that telling us? It's telling us x has to be pi over 6 and 7 pi over 6. Now they want to know, when does tangent equal 1? Well, from the unit circle, you should remember tangent is 1 when x and y are the same, and x and y are the same when they're both root 2 over 2. So we're talking about 45-degree reference angles now. And when's the other place where tangent is positive? It would be down here in quadrant 4. It wouldn't be across here. It wouldn't be down here. It's diagonal. So this time phi is 1 pi over 4 and 5 pi over 4. Okay. So when does tangent equal root 3? Well, it would be root 3 when the numerator is root 3 over 2 and the denominator is 1/2. Then the 2's would cancel, giving you your thing. And with tangent, it's y in the numerator. So when does y equal root 3 over 2? Right here. And here. So x equals pi over 3. And 4 pi over 3, because remember this is 3 pi over 3. So we're traveling an extra pi over 3 to get here. So we went 3 plus 1 more, so that's 4 pi over 3. Okay, then we finish this page on kind of an easy one. Sine is y, so when will sine be negative 1/2? That would be here. That's negative 1/2. The other place where y is negative would be here. So it's those two purple positions, and that means those are pi's over 6. It's more than 6 pi over 6, so it's 7 pi over 6. And then it's 1 pi over 6 less than 12 pi over 6, so 11 pi over 6. All right, just 30 more to go. Can I reasonably do this? Yes, I guess so. Maybe one kid will say thank you to me if I actually do all these. Maybe that'll make it all worth it. Is one of you will actually look me in the eyes and say thank you. All right, I'm gonna keep going. Why not? It's 107, but that's okay. All right. Ba-ba-doo-ba-doo. My voice is getting hoarse. Okay, same deal. This is sine, it's y. Y is negative. The big negative value, root 3 over 2, would be here and here. So, got it. You would tell me that x is equal to, what are these positions? Those are pi's over 3, because they're 60 degrees. So it's 4 pi over 3, and 7 pi over 3. Again, how come? Because this is 3 pi over 3. Uh-oh, I'm wrong. I knew something felt wrong. That's why I switched into explaining mode again. I was explaining it more for myself. All right, this is 6 pi over 3. So one more is 4 pi over 3. One less is 5 pi over 3. I screwed that up. My bad. All right, when is sine equal to 1 over root 2? Again, they're being a little tricky here. We really should be calling this root 2 over 2. That triggers 45-degree reference angle thoughts in your head. It's also positive. So when is sine positive? Of course, quadrant 1, and of course, quadrant 2. So you want these two positions, which are 1 pi over 4 and 3 pi over 4. Okay, now when does sine equal negative a half? Well, negative a half as a y value is your 60-degree reference angles. So it'll be down here, and it'll also be down there. For those two angles, there's a pi's over 6, so this will be 6 pi over 6. This would be rewritten as 12 pi over 6, and if you do that, then it's pretty clear these angles are 7 pi over 6 and 11 pi over 6. Finally, when does cosine equal 0? Well, cosine is an x value, and x is 0 in these two positions on the y-axis. So that's pi over 2 and 3 pi over 2. I'm sorry, I have like no stamina though. Is there like a break? Do we actually go by one by one by one? 46, 47, 48, 49, 50. Oh, jeez, we really do. Ugh. All right. Well, think of how rewarding it's going to be when we finish. All right. 46. Where is tangent undefined? This is a good question, so I'm glad I didn't give up. When is tangent going to be undefined? Well, what is tangent? Tangent is y over x. We are undefined when our denominator is 0. So essentially, when x is 0, and x is 0 in those same two positions we were just in. So pi over 2 and 3 pi over 2. So somebody screwed up here. It just says tan. It's got to say tan of some variable. And that variable should really be theta. So for this problem, theta would be, what did we just say? Pi over 2 and 3 pi over 2. Okay, when is cotangent 0? Well, cotangent is x over y, and it is 0 when the numerator is 0, and the denominator would be 1, because remember, we only get zeros when we get ones. So x being 0, oh, well, that's the same two spots again. Getting a little boring here. So phi is pi over 2 and 3 pi over 2. Then we get a good one. So how do you get 1 over root 3? 1 over root 3 comes from a 1/2. That's over a root 3 over 2. And with cotangent, it's x over y. So you're looking for x's of 1/2. X is 1/2 here. Again, x is also a half here, and here, and here. So when is cotangent positive, remember? Is it positive when we're above the x-axis? No. Is it positive when we're to the right of the y-axis? Nope. It's positive when both x and y are positive or both x and y are negative. Remember, it's these quadrants, quadrants 1 and 3. Tangent and cotangent are different from the other ones. So for this one, we'll say x equals pi over 3. And 4 pi over 3. And lastly, they want to know, when does cotangent equal 1? It would be great if by now you just knew that was 45. 45-degree reference angle. Why are we getting 1? We're getting 1 from a root 2 over 2 divided by a root 2 over 2. That means we're talking about 45-degree reference angles. So we are here. And again, we are not here, because here cotangent would be -1, because we'd be doing a negative divided by a positive. We need to be down here. So get rid of this. So that's 1 pi over 4 and 5 pi over 4. Okay. How do you get root 3? You do root 3 over 2 in your numerator and 1/2 in your denominator. Cotangent is x over y. So when does x equal root 3 over 2? Pretty sure that's here at 30 degrees. Pretty sure will also be positive here at 30 degrees in quadrant 3. That's pi over 6. All right, cotangent is negative. Cotangent is undefined when the denominator is 0. So y equals 0. Y is 0 here and here. That's 0 and pi. All right, tangent. There you go. Tangent is y over x again, remember. For tangent to come out negative, we need the signs to be different. So we're in quadrant 2 and 4 this time. And we need the y's to be 1/2. So we know we want 30-degree reference angles. So we want those two positions. So that's going to be 5 pi over 6. And this one is 11 pi over 6. And finally, for this one, cosine is just an x coordinate again. X is 1/2. Geez, where's x 1/2? 60 degrees. And if we're talking about x, then we do want to just be to the right of the y-axis. So the other position is right here. And that is pi over 3. Yeah, pi over 3 and 5 pi over 3. All right, we're up to 53. Getting there. All right, remember that 1 over root 2 is the same as root 2 over root 2. Cosine is x. X would be root 2 over root 2, or would be root 2 over 2 here and here. That's 54. When is x equal to root 3 over 2? Here and here. So that is yep. When does cosine equal 1? Right here. And nowhere else. So x equals 0 only. And when does x equal negative 1/2? Negative 1/2 would put you here and here. And those two positions are 2 pi over 3. And 4 pi over 3. All right. When is tangent negative 1? Remember, tangent is only 1 when you've got the root 2 over 2 over the root 2 over 2. It's your 45-degree reference angles. And so you need one coordinate negative. So that means quadrant 2 and 4 are your only bets. And it's 45-degree reference angles, which means x can be 3 pi over 4. And 7 pi over 4. Then when is tangent 1 over root 3? That means the numerator is 1/2 and the numerator is y. So you want y to be negative 1/2. That's here. Or y could be positive 1/2 and x could be the negative root 3 over 2. So it's these 30-degree reference angles from quadrants 2 and 4. And those are both pi over 6s. The first one is 5 pi over 6. And the next one is 1 pi over 6 away from being 12 pi over 6. So it's 11 pi over 6. Okay, cotangent of the same number. That means the coordinates have swapped. So you want x to be 1/2 now and negative 1/2. So that would be this position, or this position. So instead of the pi over 6's, it's pi over 3's. So it's 2 pi over 3. And 5 pi over 3. Then when is cotangent equal to -1? It's the same. It's going to be those 45-degree reference angles. And you're going to want one where the x is negative and one where the y is negative. So it's here and here. Same exact answers from the first one. So we'll say phi. It's 3 pi over 4. And 7 pi over 4 again. Just like in number 58. All right. Oh, getting so close. Okay. I always think the tangent and cotangents at 30s and 60s are the hardest. How do you get root 3? You must have had your root 3 over 2 in your numerator and your 1/2 in your denominator. Cotangent is x in the numerator and y. We are trying to be negative. So, negative root 3 over 2 puts me here. Positive root 3 over 2 with a negative y puts me here. So 62 has answers in those two positions. Those are both pi's over 6. So it's 5 pi over 6 and 11 pi over 6. Okay, when does secant equal 0? Trick question, never. Okay, why is there no solution? Because again, secant has to come from a reciprocal, right? So if it's 0 over 1, then that must have come from 1 over 0, which was undefined, right? There's no place where we can get that. Or maybe a better way to explain it now that it dawns on me. Secant's reciprocal of cosine, which is x. So this is r over x. To get 0, r would have to be 0. And r can never be 0. If our radius is 0, then the whole situation degrades down to just a single point. And that, we can't do that. We can't abide that. So we got no solution for that. Now on the other hand, 2 over root 3, that sure looks a heck of a lot like the reciprocal of root 3 over 2. And secant is the reciprocal of cosine. Cosine is x's. So for this problem, you're basically looking for the places where x is equal to root 3 over 2. And those places, of course, are here and here. So that means we're getting a pi over 6 and an 11 pi over 6. Okay, finally, remember that root 2 is the reciprocal of root 2 over 2. And secant is the reciprocal of cosine. Cosine is x's. So again, we're just looking for the coordinates or the points where x is root 2 over 2. That is here, 45, here, 45. So v equals the 1 pi over 4 and 7 pi over 4. Oh my god, I've never been more sick of anything in my life. Okay, secant, cosine, cosine x, 2, reciprocal of 1/2. X is 1/2, here and here. Okay, secant, cosine, cosine is x, negative root 3 over 2. X's that are negative root 3 over 2 are here and here. Right, you better be with me. V equals, these are pi over 6's, so this is 5 pi over 6. I'm losing my voice. 5 pi over 6 and 7 pi over 6. Okay. Another root 2, so that's the reciprocal of root 2 over 2. secant cosine x. Where does x equal negative root 2 over 2? It's here at these 45-degree reference angles. So those are 3 pi over 4. And 5 pi over 4. And finally, basically this is just saying when does x equal negative a half? X is negative a half here and here. So those are pi's over 3. So 2 pi over 3. And 4 pi over 3. Oh, is this it? Is this the end? Yes. Oh my god. We're going to do it. We're going to make it. Okay, when does cosecant equal that? Cosecant's reciprocal of sine, which means we're thinking about y values in our head now. And we're basically just looking for y values of root 3 over 2. Those are the big ones. So that's down here at 60-degree reference angles. So it's those two blue positions. And those are pi's over 3. So one of them is 4 pi over 3. The other one is 5 pi over 3. No. Yes. Yes. Okay. This guy's asking, cosecant is still sine, it's still y, it's still asking when does y equal root 2 over 2? Because remember, the reciprocal of root 2 over 2 is 2, which feels weird, so let me just show this one more time for anyone who missed it. The reciprocal of root 2 over 2 is 2 over root 2. But by the time you clean up the denominator, you've got a 2 root 2 over a normal 2, which you can cancel. So the reciprocal of root 2 over 2 is basically make the 2 go away. That feels pretty weird, but hey, that's the way it is. So when does y equal root 2 over 2? Positive. Y here and here at the 45-degree reference angles. So you know that phi is going to be 1 pi over 4 and 3 pi over 4. Alright, cosecant is still y, reciprocal is 1/2, and it's negative. So I feel like that's here and here. Those are pi's over 6. First one being 7 pi over 6. And the last one being 11 pi over 6. And finally, truly finally, cosecant is still y. For the reciprocal of the y value to be undefined implies that the y must have been 0. The reciprocal of 0 is undefined. So y is 0 exactly here and exactly here. So we can say phi is 0 and pi. All right, y'all know the drill. Do your homework. Hit me up if you have any questions, I guess through email. Hopefully I'll see them and be able to respond. Good studying. See you in class.